Have you ever looked up at the night sky and wondered, how did all those stars come to be? Each star has a story, a cosmic narrative of birth, life, and death. These celestial bodies burning bright in the vast expanse of space are not mere ornaments. They are cosmic powerhouses, the heart of all existence. Fascinating, isn't it, that such enigmatic entities shape our universe? So buckle up, space travelers. Today, we unravel the cosmic mystery of the birth and death of stars. Stars are born in the depths of space, in vast clouds of gas and dust known as nebulae. Picture this, a nebula, a giant cosmic nursery, brimming with the raw materials needed to form stars. A portion of this nebula starts to collapse under its own gravity, pulling in more and more material. As this material condenses, it begins to heat up and spin, creating a warm, swirling ball of gas and dust. This is what we call a protostar. Now here's where things get exciting. The protostar continues to grow and heat up, until its core becomes so hot that hydrogen atoms begin to fuse together, releasing a tremendous amount of energy. This process, known as nuclear fusion, is what makes a star shine. The protostar has now graduated to become a main sequence star, stable and glowing with the energy of millions of suns. And so, a star is born, ready to shine brightly in the cosmos. Once a star is born, it enters what astronomers call the main sequence stage. It's like the star's prime. Its heyday of stellar life, if you will. This is when a star truly comes into its own, shining brightly, and making its presence known in the cosmos. At this stage, the star's core is a hotbed of nuclear fusion. It's a fiery, powerful process, where hydrogen atoms are forced together under immense pressure and temperature. As they collide and combine, they form helium. This process, known as hydrogen burning, is the heart of a star's life. It's like the star's furnace, constantly burning, constantly converting hydrogen into helium. And what's fascinating about this process isn't just the transformation of elements. No, it's the energy that's released. This energy radiates outwards, escaping the star's core, traveling through its outer layers, and finally reaching us as light and heat. This is the light that makes the star sparkle in our night sky. It's the heat that has allowed life to flourish on our own planet. But what happens when the hydrogen fuel starts to run out? Well, the star doesn't just switch off, it begins to change, preparing for the next stage of its life. But that's a story for another time. For now, just imagine. Each star you see in the night sky is a fiery cauldron of nuclear fusion. The star continues to shine, its light traveling across the universe. But like all things in the universe, a star's life must come to an end. As the celestial clock ticks, a star burns through its fuel, sparking a series of events that lead it to its ultimate fate. The magnitude of its end, however, is determined by the star's initial mass. Let's start with the lighter stars, those with a mass less than 8 times that of our sun. These stars burn their hydrogen fuel slowly over billions of years. Eventually, when the fuel runs out, the star expands, becoming a red giant. The core of the star shrinks under gravity's pull, while the outer layers drift away into space, creating a planetary nebula. The remaining core, now a white dwarf, gradually cools and dims over the course of billions more years. But what happens when a star is heavier, say, more than 8 times the mass of our sun? Well, these behemoths live fast and die young. As they burn through their fuel, nuclear reactions in their core create elements up to iron. But iron doesn't burn. It accumulates in the star's core, causing it to collapse under its own gravity. This implosion bounces off the core, triggering a supernova explosion. In a supernova, the star shines as brightly as an entire galaxy, albeit briefly. This is not a gentle farewell. The star's death throes scatter elements throughout space, seeding the universe with the building blocks of future stars, planets, and perhaps life itself. But the story doesn't end there. The remnant of the supernova can become a neutron star, an incredibly dense object. If the star was massive enough, the gravity can be so intense that it forms a black hole. A point in space where gravity is so strong that not even light can escape. Regardless of the path they take, every star leaves an indelible mark on the universe. They shine brightly, burn passionately, and even in death, contribute to the cycle of stellar life. In a brilliant burst of energy, the star ends its life, leaving behind a cosmic legacy. From birth to death, the life cycle of a star is a journey of cosmic proportions. As we've explored, this journey begins in the dense and chilly molecular clouds, where gravity pulls matter together to form protostars. These protostars then mature, fusing hydrogen into helium and radiating energy, becoming what we commonly recognize as stars in their prime. The types of stars that emerge from this process are as diverse as the universe itself. There are red dwarfs, stars that are smaller, cooler, and more common than our own sun. There are also the blue giants, rare behemoths that burn bright and die young. And then, there are the spectral classes, a categorization system based on a star's temperature and color, ranging from the hottest, bluest O-type stars to the coolest, reddest M-type stars. But the life of a star doesn't end in its prime. As a star exhausts its nuclear fuel, it undergoes dramatic changes. It may swell into a red giant or a supergiant, engulfing its surrounding planets. Or in the case of the most massive stars, it might explode in a supernova, an event so powerful that it can outshine an entire galaxy. The remnants of these stellar deaths can form white dwarfs, neutron stars, or even black holes, celestial bodies that continue to fascinate and puzzle astronomers. And the expelled matter from these deaths can, over millions of years, coalesce to form new stars, continuing the cycle of stellar birth and death. This cycle, this cosmic dance of birth, life, and death, plays out across the universe, creating a symphony of stars. Each star, regardless of size or lifespan, contributes to the cosmic melody. It's a symphony that's been playing for billions of years, and one that will continue long after we're gone. The next time you gaze at the night sky, remember, every star has a story, a cosmic journey from birth to death, and in this grand symphony of the universe, each star plays a pivotal role.